So given f of x equals x to the 3 plus 4 x to the 2 plus x plus 9, we are being tasked to find its derivative. Now looking at f of x, we can clearly see this is a polynomial. So for this, we'll need to use the power rule. So the power rule, all that is the derivative with respect to x of x to the n, where n is any number, simply is n times, so you just bring the n out front, n times x, n minus 1, and you just minus that exponent by 1. And what we also know is if we take a derivative, and if we have a polynomial, let's just say this is x1 plus x, oh, I don't know why it's doing that, plus x2 plus so on, dot, dot, dot. This actually equals the derivative of x, x1 plus the derivative of x, x2, and so forth. So combining both what we know, we can now find its derivative. So I'm going to denote it with a fancy x. So f prime of x equals, so for x to the 3, we know we just bring the 3 down and we'll minus the 3 by 1. So we'll bring the 3 down. X, 3 minus 1 is 2. Next, we have a 4 in the way. So this is actually 2 times 4, which is 8, times x. 2 minus 1 is 1. So it's just x to the 1. Next, we'll bring, technically, x to the nothing is just x to the 1. So this is a 1 right up here. So I'll bring the 1 down. And then that x to the 1 minus 1 is x to the 0, which also equals 1. So technically 1 times 1, but I'm just going to write down the 1. And now you'll see there's a constant. Technically, 9 can be written as 9 times x to the 0, because x to the 0 is 1, as we saw before. So if we bring that 0 down, this will be 0 times this number, which would be 9x to the minus 1, which, once we do that, will equal 0. So that's not 9 equals 0, but that's 9 d by dx equals 0. So that was kind of complicated. Anyways, essentially, the derivative of a constant is just 0. So this is our final equation. It is f prime of x equals 3x squared plus 8x plus 1. And that's it.